6.6 will be your inverse function. So if you think about inverse operations, if you have, if you're solving an equation, say x plus 3 equals 5, you would know you would subtract your 3. That is because those are inverse operations. They undo each other. Okay, so inverse functions are pretty much like that. They are in reverse order. You're going to solve those inverse functions using the inverse operations in reverse order. Okay, so what you're going to do first is always interchange your x and y. So your first step will always be to flip your x and y. Then you're just solving for the new y using whatever order of whatever inverse operations you're going to have to do. Okay, and then once you get down to your y equals, you are going to write your answer with y to the -1, and that's a notation. Okay, so up until this point, we always saw that a negative exponent meant you have to flip it. Okay, that's not what we're doing. This is your notation for inverse equations. Okay, so you're not going to end up flipping anything. Okay, that is just your notation, just like f of x is a notation. Okay, so our first example that we're going to look at is if we just have a linear y equals 3x plus 4. Okay, my first thing I do is interchange the x and y. So it now becomes x equals 3y plus 4. Now, if I want to solve for y, what am I going to do? Subtract your 4. So that leaves me with 3y equals. How do I write the x minus 4? Does that become negative 4x? It is just x minus 4. Okay. When we divide by 3, every term gets divided by 3. So we have, you can leave it as your x minus 4 divided by 3, but if you know it's linear, okay, linear, you don't write like this. If I asked you to graph linear, this is not what you would have. Remember, linear is y equals mx plus b. Okay, so if I have x divided by 3, that is the same as 1/3 x, then you're minus 4/3. So that's how I would like to see it. That way, when you're doing graphs, when we get to the graphs, if you have a linear, you can actually look at that and you know that's an mx plus b. Here, you don't recognize this should be y equals mx plus b. You understand the difference there? Okay, so now that I've got y by itself, I can tack on my inverse notation. So this says the inverse of y is equal to 1/3 x minus 4/3. Okay, so then my next example, I've got y equals 1/4 square root of x minus 2. So my first step, I interchange x is equal to 1/4 square root of y minus 2. Okay, now if I want y, that means I need this radical by itself. So what do I need to get rid of? Before I get rid of the square root symbol, I need to get rid of this 1/4. I'm going to multiply both sides by 4 to cancel out that fraction. So anytime you have a fraction, you're going to multiply by the reciprocal. Okay, so then 4x is equal to that 1/4 and 4 cancels. Now I have the square root of y minus 2. Now how do I get rid of radicals? I square both sides. I'm going to write this over here. When I square this radical, that will undo it, leaving me with y minus 2. And then the 4x as a whole squared becomes what? 16x squared. You have to be careful with that. You are taking the 4 and squaring it and the x. So if you need to write your little distribute lines so you know that both of those get squared, then do that. Okay, so now I need y by itself. What am I going to do? add 2. So y equals 16x squared plus 2. Do I have anything to combine?
No.
No, so I can tack on my inverse notation, and that's my answer. Okay, we good with those examples? Okay. So now we've got y equals the cube root of x minus 2 plus 7. Okay, so I'm going to interchange my x and y. X equals the cube root of y minus 2 plus 7. I want the y by itself, so that is part of the radical. So if I want the radical isolated, what do I have to get rid of first? I need to subtract 7 from both sides. So that leaves me with the cube root of y minus 2 equals x minus 7.
Does it matter where you write first, x minus 7?
No, you can leave it x minus 7 equals the cube root of y minus 2. I just know my y ends up on the left at the end, so I just, as soon as I start writing it that way, that's whatever. But it doesn't matter. So from here, how am I going to get the y? I need to cube both sides to get rid of that radical. So that leaves me with y minus 2, because that cancels. Now, when you have this x minus 7 cubed, you can leave it. All I'm going to be doing is adding a 2 at the end, so you can leave this x minus 7 cubed. You do not have to write that 3 times and keep multiplying and FOILing and all of that. I'm okay if you leave it just like this. Okay? Then, all you have to do is add your 2. So that leaves me with x minus 7 cubed plus 2. I can't combine anything. There's nothing to simplify, so I tack on my inverse notation. And the inverse of y is equal to x minus 7 cubed plus 2. Yeah.
So if we did forget on this to not write it 3 times, will we get it wrong?
No, if you wrote it 3 times and you kept FOILing and multiplying, I would follow what you do.
Okay.
Okay, do we have other questions? Y'all understanding my steps? Okay, each problem is going to be different. Okay, as long as you're knowing your inverse operations, then you're okay. All right, so I've got y equals negative 1/2 cube root of x plus 1. Okay, so I'm going to interchange x equals negative 1/2 cube root of y plus 1. So then, if I want this radical, because it's got the y, what am I going to do?
Times -2.
Multiply both sides by -2 to get rid of that negative 1/2. So then I'm going to rewrite cube root of y plus 1 equals negative 2 times x is negative 2x. And then I'm going to do what?
Cube it.
Cube both sides to get rid of that radical. So that leaves me with y plus 1 equals negative 2x as a whole cubed is going to give me what? Negative 8x cubed. Remember, you've got to distribute. When there is no plus or minus, everything takes on that cube. Okay, see how here we just had x minus 7 cubed, we didn't distribute that cube to it? That's because there is a plus or minus in the middle of these two terms. When they are just multiplied, this is like what we did in the first part of chapter 6 with our properties of exponents. Okay, there's a difference there. So then my last step would be to do what? Subtract your 1. So the inverse of y is equal to negative 8x cubed minus 1. Good? So our next example, we have y equals x plus 4 squared. Okay, if we have that, we're going to change x equals parentheses y plus 4 squared. If y plus 4 is being squared, what do I need to do to get that y starting to get by itself? You're going to square root it. You do the inverse. So if it's being squared, you square root both sides. Okay, when you square root, that's going to cancel that square, leaving you with y plus 4 equals. Now, when you take the square root of anything, what do you always have? A plus or minus. So that gives me plus or minus square root of x. And then subtract your 4, so y equals. You can either write it -4 plus or minus square root of x, or plus or minus square root of x, and then just make sure your -4 is on the outside of that radical. So you can write the inverse of y equals plus or minus square root of x minus 4, or you can write it the inverse of y is equal to -4 plus or minus the square root of x. I'm okay with either one. Okay. So the next example, we've got y equals -4 times the cube root of 2x plus 4 divided by 3. Now this one's a little bit bigger than the ones we've done. You're all good and confident with your skills with the first 5 examples? Okay. So here, you're still thinking the same process. You're going to interchange your x and y, so x equals -4 times the cube root of 2y plus 4 divided by 3. Now I want the y is under a radical. The radical is not by itself yet.
Plus 4.
Now what is happening with the radical and the -4? You're multiplying. So what's the opposite of multiplying? I have to divide both sides by -4. Okay, so I've got the cube root of 2y plus 4 divided by 3 equals, now I can write this -x over 4. That's okay right now. Because what am I going to have to do with my very next step? I need to get rid of this radical to be able to separate that y. So if it's a cube root, I'm going to cube. Now you have to be careful with this. Okay, so that will undo its radical, leaving me with 2y plus 4 divided by 3. Now when you cube -x over 4, the -x takes on the cube and the 4 takes on the cube. Okay, so -x as a whole being cubed, negative times negative times negative, still stays -x cubed. Then 4 cubed is going to give me what? Y'all follow me so far? Okay. So now, if I want this y, it's in the numerator. What do I have to break away first? I need to get rid of that denominator, so I'm going to multiply both sides by 3. That will cancel that denominator, leaving me with 2y plus 4 equals, now when you multiply by 3, remember you only multiply to the numerator when you have a fraction times a constant, because that's the same as saying 3 times 1. Okay, so this is a -3x cubed over 64. Now I would check, could you simplify -3 over 64? Anytime you have a fraction, try to check if it simplifies. It does not. Okay, so we're going to leave it like that. So now, if I'm just looking at 2y plus 4, regardless of what's over here, what do I know I need to do first? Subtract your 4. So when you subtract your 4, you're going to have 2y equals -3x cubed over 64 minus 4. Now, can I leave it like this? No. What do I need to do? Something with that 4. Okay, I've got a fraction and a constant. Okay, I need to get common denominators. Okay, so you're going to get a common, I'm going to abbreviate denominator, but you need to get common denominators. So this constant, this -4, I really want to have a denominator of what? 64. So I'm going to multiply by 64 over 64. So I have 2y equals -3x cubed over 64 minus 4 times 64 is going to give me 256 over 64. All we did was get common denominators, okay? So now, I would go ahead and combine this because I have the common denominator. I'll write it up here. So that's 2y equals, my denominator is 64. My numerator is just going to be the -3x cubed minus 256. Now what do I need to do? Divide by 2. What did I say last class when you have a fraction divided by something? How do we treat that? How do we come down to a final answer? You do your keep, change, flip. Y'all remember that? Okay, so we keep our numerator, which is the full -3x cubed minus 256 divided by 64. And we multiply that by the reciprocal of the full denominator. My denominator is 2. So what's the reciprocal of 2? 1/2. Right? Because 2 is just 2 divided by 1. So we can flip that to be 1/2. So now we're just multiplying 64 times 2. So y equals -3x cubed minus 256 divided by 64 times 2, 128. Now I would check, can any of those be divided and simplified? Well, -3 is my smallest number, so can 128 be divided by 3? No. So I'm going to tack on my inverse operation, and that be my answer. So they can be easy, and they can be a little more difficult.
You wouldn't divide like -256 divided by 128?
Because not all 3 can be reduced, I would not. You would have to split it, and that defeats the purpose of finding the common denominator.
Is it always gonna be like that with the common denominator?
Is it always be like what?
Like, since, do you take from the original, like how it was 64?
This,
Mm-hmm.
when you create the common denominator, yes, whatever this is, you're multiplying by that denominator. If it's just a constant. Okay, do we understand the other steps? I know that was a big problem, but if you do just little bitty step by steps, you're still doing inverse operations all the way through. Okay, and then common denominator is not a new concept. Okay, so our last example, we've got y equals 1/3 times the square root of 3x minus 5 divided by 2. So it's kind of like the same thing, except instead of having a whole number out front being multiplied that you divide by, you now have a fraction. So how do I get rid of this fraction? I multiply both sides by what?
3.
Well, what did we miss?
3
first?
over 1.
Yes, but what did we not do?
We didn't change that.
Oh.
We didn't change the x and y. So x equals 1/3 square root of 3y minus 5 divided by 2. Then you can multiply by your 3. Okay, that will cancel that 1/3, leaving me with the square root of 3y minus 5 over 2 equals 3 times x is 3x. Sorry, that looks like a blob, but that should be a 3. Okay, now what am I going to do?
Square.
I'm going to square both sides because I want to get rid of that square root. So that leaves me with 3y minus 5 over 2 equals, what's on my right side? 9x squared. Please make sure you square that constant. That's one of those most common mistakes. Remember last class I was telling you I have a sticky note? One of the sticky notes is that not squaring this. Okay? So, now what do I need to do? Multiply both sides by 2 to get rid of that denominator. So then 3y minus 5 equals, what's 9x squared times 2? And then what? Plus 5. So 3y equals 18x squared plus 5. And then divide both sides by 3. Y equals, now here, the 18 can be divided by 3, but the 5 cannot be divided by 3. So if you write it as 2 separate terms, okay. If not, you can just do your 18x squared plus 5 divided by 3. I'm okay with that. I'm also okay with the 6x squared plus 5/3. Whichever way your brain sees it automatically, then I'm going to follow you. I've got my inverse operations. There's my answer. Okay, so these two look pretty much the same. One had a whole number, one had a fraction. One with a fraction, you do less steps because you're not dividing out by things. So you are multiplying. So the one with the fraction is actually a little bit easier. Y'all understand those steps? We have questions. This is the algebra. If you're just finding an inverse algebraically. Okay? So then the next page, we are now going to not only find the inverse algebraically, but we are going to graph the original and the inverse. Okay, so what that means is your inverse functions, we've been saying, or I said that your inverse operations undo each other, your inverse functions do as well. Okay, and what happens is that the inverse function reflects over y equals x. Okay, not the x-axis and not the y-axis, the line y equals x. Okay, so the inverse is the reflection of its original across y equals x. Okay, so what we're going to do, if you want to, you can find the inverse equation first. This says find the inverse equation first, graph y equals x, because that's your symmetry line that it reflects over. And then graph the original, graph your inverse. If you want to graph your original, get it done with, you can do that also. Whatever you want to do as far as find the inverse algebraically first or graph it first, it's up to you, okay? I will probably find the inverse and then graph everything all at once, okay? Like the steps say. Now, what is going to be different here is we're not just looking at what is the inverse. We have to know, is it a function or not? Okay, so you're going to use the vertical line test to determine if the graph is a function. That's what you learned in Algebra 1, okay? If a vertical line intersects the graph at more than one point, then it's not a function, okay? So you're going to use f of -1x if the inverse is a function, and you're going to use y to the -1 power if the inverse is not a function. So you have to find the inverse, graph the original, have your axis of symmetry, reflection line, graph your inverse, and be able to analyze if it's a function or not. Okay? So our first one is a linear function. we have f of x equals 1/2 x plus 1. Now, if it's linear and you want to go ahead and graph it, we know that our slope is what? Our slope is 1/2, right? Because linear is y equals mx plus b. Our y-intercept is 1. Okay? Now, no matter what, you should always have the y equals x line. Now, your y equals x line, that slope is 1, and that y-intercept is 0. So that's always going to pass through, that's your parent function for a linear function, just FYI. Okay, that's going to pass through your origin, and it's always going to go up 1 to the right 1. Now, you have your IDs, so you can either use your ID or you can use your ruler. This is going to be a dashed line because it's your reflection line. That's your axis of symmetry.
What did we just, like, I'm confused what we just put on the graph.
This is your, so because inverse functions are reflections of the original, it always reflects over y equals x. So this is our, what we say like the axis of symmetry, basically. That is showing you, like once you have the two graphs, you will see it reflects over this line.
Okay.
So how we've done transformations in the past, we say it reflects over the y-axis, it reflects over the x-axis. This is going to be a reflection over this line. So every graph will have this. Every graph you do. Okay? So then we can take our original 1/2 x plus 1 and we can plot that. So we can do our y-intercept at 1. If my slope is 1/2, where do I go? Up 1 to the right 2. Up 1 to the right 2. You do enough to get an accurate estimation of what that graph looks like. So that is my original. Okay, now my inverse I'm going to do algebraically. We know f of x is the same as what? We know f of x is the same as y. So I still need to interchange my x and y. Okay, so I'm going to rewrite that. X equals 1/2 y plus 1. And how do I solve for y? Subtract your 1. So 1/2 y is equal to x minus 1. And then how do I get rid of that 1/2? Multiply both sides by 2. So y equals, when you multiply x minus 1 as a whole times 2, that's 2x minus 2. Make sure you distribute that to everything. Okay? So here, 2x minus 2 is my inverse equation. Okay? So my slope would be what? 2, and my y-intercept would be -2. So I can plot -2 on the y-axis, and I go up 1, 2 to the right 1. Up 1, 2 to the right 1. Up 1, 2 to the right 1. Make sure you extend it and you have arrows. Now visually, do you see how it reflects over that y equals x that we graphed? Okay, so we need to now determine, is our inverse a function or not? So that vertical line test tells you if you just take any vertical line and you draw it, imagine drawing it. If I'm only focused on this one line and I do a vertical line test, does it cross that one line more than once for one vertical line? Like if I take my pen, you take your pencil and you put it on that graph. Is it going to cross this one line, ignore the other two lines, that one line more than once? Or is it only going to intersect it at one point? 1 point. That means it's a function. So we're not going to just box this. We're going to express that as f to the negative 1 of x equals 2x minus 2. We just put it in the proper notation. Okay? All linear functions, or I'm going to say all linear inverses, are functions. So that means every time you have a linear function, its inverse, when you graph it, will be f to the negative 1 of x. Okay? Do we understand what we did?
You have to start from where like it. Well,
So you always have your axis of symmetry because that's your reflection line. You graph your original if you want to do that first. Find your inverse algebraically and graph it. And then you do the vertical line and you see how many times it crosses for each vertical line. If it only crosses that graph once, it's a function. If it crosses it more than once, it's not a function.
which line do we check?
The inverse. That's why I was covering up these. You're only looking at that one. So if you want to do your inverse in another color so that you know that's what you're looking at, you can do that.
And do you have to start from the middle, like where? It's all-
No, it's just anywhere along that function. You'll see, when we do our next example, you'll see very clear, like, what is going to be a function and what is not going to be a function. Okay? All right, our quadratic function. If you have f of x equals x squared plus 3. Okay? Now, we did quadratics all the way back in chapter 3. That was the second 6 weeks, I think, or even the first 6 weeks. Nothing goes away in Algebra 2. You build on everything, okay? So what we did with quadratics in chapter 3, we're still doing in chapter 6, okay? So with quadratic functions, you could have vertex form, which is y equals a parentheses x minus h squared plus k. That's vertex form. Or you could have standard form, which is y equals ax squared plus bx plus c. That's our standard. Okay? When all you have is an x squared and a constant, you can do either one of these. I will always lean to vertex unless I have that bx term there. If I have x squared and an x, that's my standard. If I only have one x squared term and I don't have another x term, it's x squared and a constant, I'm going to go to vertex form. Okay, so remember your vertex is hk. Y'all remember that? Okay. So if I have x squared plus 3, what could my vertex be? I don't have parentheses. So what would that x value of the vertex be? What could I be adding or subtracting that won't change this? If I had a 1, it would be x plus or minus 1, right? If I don't have anything there to add or subtract, what is that? A 0. So this would be 0, and then what's the y value of my vertex? The 3. Okay, so I always lean to vertex form because I can look at that. If I have parentheses, whatever's in parentheses is the x value of the vertex. But remember, what do we have to do with that? Opposite signs. Okay, you have to be careful with that. And then whatever is added or subtracted at the end is your y value of the vertex. Okay, so here, that's how I'm going to treat it. Okay, Now, with quadratics, we always had to do a table. Y'all remember that? Anything but linear will have to have a table. Okay? So our vertex goes in the middle, 0, 3. Do y'all remember how to build your table? You do 2 points above and 2 points below. So here, since it's 0, 3, it happens to be -1, -2, +1, +2. But if it were 3, then you'd have 2 and 1 and 4 and 5. So it just depends on what your x value is. You do your 2 points above, 2 points below. Okay? Now, with your y values, remember you store each of these x values in to your equation. So I've got -2 stored for x. And I take x squared plus 3. That gives me 7. I take -1 stored for x. X squared plus 3 will give me 4. 1 stored for x gives me 4. 2 stored for x should give me what? 7. Because it is a symmetric graph. Okay? So, we always have our axis of symmetry y equals x. So that's always through the origin of 1 over 1 with a slope of 1, y equals x. Oh, that should have been dashed. Just gonna imagine that that was dashed. Half of it will be dashed. Okay, then I can plot my points for my parabola. -2, 7. -1, 4. 0, 3. +1, 4. And +2, 7. Okay. Are we all caught up? Good. Now we need to find the inverse algebraically. So our first step of finding it algebraically is to do what? Interchange your x and y. So x equals y squared plus 3. How do I solve for y? Subtract 3. Y squared equals x minus 3. If y is being squared, what do I need to do? Square root it. Every time I have a square root, what do I have? Plus or minus. So y is equal to plus or minus square root of x minus 3. Okay, now that's my equation. I can't box that yet because I don't know if it's a function or not. Okay? Now, the thing about inverse, algebraically we keep interchanging our x and y. That's because your inverse reflects over y equals x. Okay? So, what we're going to do is not figure out a table for this. You are going to interchange your x and your y for your inverse table. Now, I always label which table is my inverse because I don't want you guessing what is what. So that is my original. And this is my inverse. So I'm going to take all of those x's, they become the new y's. I take all of those y's, those are the new x's. Because of the fact that inverse functions reflect over y equals x, you can flip those x and y's. So let me tell you that if you get to the test, bless you, and you forget or you get stuck, you don't know how to solve it algebraically, you could at least graph it, right? If you can get your first graph, you could take these tables and interchange them. You could at least graph the inverse if you can't solve it correctly, right? So our inverse, we've got 7, -2, 4, -1, 3, 0, 4, +1, and 7, 2. So this is what I meant by you get very clear. If you take your pen or pencil and you put it on that graph, how many times does your pen or pencil go through that one graph?
Yeah.
Twice. That means it's not a function. So that's what it would look like. Okay, with your vertical line test. By definition, a function, each input has exactly one output, meaning no repeated x values. Notice that you have repeated x values in the table, means it's not a function. Okay, so we're just going to go back up here and we're going to do our y to the -1 and we're going to box that because it is not a function. Okay, so I'm going to say all quadratic inverse functions all quadratic inverses will be y to the -1 because they're not a function. Quadratics are functions, the inverses are not. Okay.
Wait, what do you mean by -1 to the -1?
Okay, so that goes up to here. So if it's a function, use your function notation for the inverse, x to the -1 of x. If it's not a function, then it's just y to the -1. Because you can't write f of x if it's not a function. So this inverse
Oh,
is not a function. So I can't do f of x. It's got to be the y.
Okay.
Okay.
but they'll all have that -1.
Yes.
Okay.
Because that's your inverse notation. Okay, what other questions do we have? All right, we have 2 more examples. Our next one is still quadratic. It's f of x equals x squared minus 8x plus 21. Okay. In the notes, I'm telling you it's a quadratic. In the worksheet and on the review and on the test, I'm not telling you it's quadratic. So what determines that it's quadratic? The exponent. X is linear. You don't need a table for linear. Quadratic is x squared. You need a table. Cubic is x cubed. You need a table. Okay? So the hardest thing is knowing what to do when. Because your examples are all going to be different. So with this quadratic, it was vertex form, so you could just do your vertex and get the table. For standard form, we're not using the graphing calculator. Does anyone remember the formula on how to find the xi of the vertex?
Was it A, B, C, 4 times?
That's your quadratic formula. Okay, so my vertex, when it's in standard form, you do x equals -b over your 2a. Y'all remember that? Okay. So we've got ax squared plus bx plus c. So x equals negative, your b is a -8, divided by 2 times 1. Mm-hmm. 8 divided by 2 is 4. So then remember you take that 4, store it for x, and you type in your function, x squared minus 8x plus 21. Y is equal to 5. So then my vertex is 4, 5. We have our table with 4, 5 in the center. To get my 2 points above, I subtract, so I get 3 and 2. And my 2 points below, I add, so I get 5 and 6. Okay. So I take 2, store for x. That gives me 9. 3, store for x. Gives me 6. 5 stored for x should also give me 6. 6 stored for x gives me 9. Okay, so you're going to have to know how to do this. You're going to have to know how to go back to chapter 3 and do all of the things that we did. Okay? So I always have my dashed line. My y equals x, axis of symmetry. Then I can plot my points 2, 9, 3, 6, 4, 5, 5, 6, and 6, 9. Okay, now to do our inverse algebraically. This is something that a lot of people forget how to do. When you get to the test or the review or whatever, this is something, even the quiz, you see it and you don't recognize what to do because it's not practiced enough. Okay? So if I have f of x equals x squared minus 8x plus 21, when I interchange those x and y's, that means my y becomes an x, and every x becomes a y. So that's y squared minus 8y plus 21. Okay? Now, I have 2 y's. My first step, I can still subtract the 21. So that tells me y squared minus 8y equals x minus 21. Okay? Now, when I have 2 y's, if your instinct is to take out a y and do GCF, you're still going to have 2 y's. Okay, so I can't do that. What I'm going to have to do is complete the square. And that was chapter 4, I believe. So when you see something like this, and I might give you a problem, I know for a fact it's on your worksheet, that it's not graphing. It's this, but not graphing. You still are doing the same work. Just because I have a graph here doesn't change the work that I do right here. Okay? So to complete the square, this is when you have 2 of your 3 terms. You're trying to create a perfect square trinomial to get it down to factor form because it's a perfect square trinomial. Okay? That's the only way you're going to get it down to 1 y. So what we do, we take that b term, which is negative 8, whichever one is with the y. Okay, you take negative 8 and divide it by 2. Negative 8 divided by 2 is negative 4. You take that negative 4 and you square it. That gives me 16.
Where did the 2 of the denominator come from?
That's just the pattern of completing the square. It will always be whatever that number is divided by 2. Will always be that. Okay? So that 16 is what we add to both sides. And it's always added because you square it, it's always positive. Do y'all remember doing this now? You would add something to both sides. So then you have y squared minus 8y plus 16 equals x minus 21 plus 16. Now the left side is a perfect square trinomial. We could get it into factored form, which is a set of parentheses squared. Okay, so we always have our variable comes down. Whatever the number you get first is the number that comes right there. This should not be completely new to you. This should be ringing a bell at some point because we did this chapter 4. Okay, then that is equal to x. Negative 21 plus 16 is a negative 5. Now that is the only way you go from 2 y's down to 1. Okay, so you might have to start this, you might have to really practice this. You have to know how to complete the square. That is one of the things that I have on the student note, most common mistakes, not knowing how to do the square. So I'm telling you now, you have to know how to do it, okay? So, when I do y minus 4 squared equals x minus 5, how do I solve for y? Square root it. So that leaves me with y minus 4 equals, anytime I square root it, I have plus or minus x minus 5. And then I do what? Add your 4. So y equals plus or minus root of x minus 5 plus 4. Okay? So for the table, our inverse, we just have to take those x and y's and flip them. This is what I meant by if you forget how to do the actual algebra, you should at least be able to graph it, right? And get your partial credit. So my y's are now the 2, 3, 4, 5, and 6. And then my x's are now the 9, 6, 5, 6, and 9. When you graph that, is that a function?
No.
No, so I'm going to tack on a -1 here. And I'm done. There's a lot to these problems. That means they're going to be weighted more than just solving it algebraically. Okay? Do you have a question on those steps? Okay, our last example is a cubic function. This is f of x equals 2x cubed plus 1. Now the cubic function, you can kind of see the same as how we say vertex form. We're not going to really say it's vertex form, but that x minus 8, let's say cubed plus 1, you can kind of compare it. Instead of a vertex, what do you have with cubic? Do y'all remember? What's that middle point of your graph with a cubic function?
Inflection.
An inflection point. This should be it. I was talking and didn't finish the K. All right. So your inflection point is that HK. Remember your inflection point, if it's in the middle of your graph, it should be in the middle of your table. That's how we build our table for cubic. Okay. So if I compare 2x cubed plus 1 to this, what would our inflection point be? Do I have parentheses? So it would be 0 and then the 1. So that's my inflection point. And then I have my -1, -2, +1, +2. So I take and build my table the same way I did with quadratic, it's just cubic. So -2 store for x, 2x cubed plus 1 gives me -15. -1 store for x gives me -1. 1 store for x gives me 3. 2 store for x gives me 17. Your cubic should not repeat. Only a quadratic repeats. Okay, so I'm going to have my y equals x axis of symmetry line. I plot -2, -15 goes off my graph. So -1, -1, 0, 1, 1, 3. 2, 17 is going to go off my graph as well. You have to know what your cubic graphs look like. And that was chapter 5. So this is proof that, you still have to retain your information that you've learned. Okay, now for the inverse, to find it algebraically, we're going to swap our x and y. So x is equal to 2y cubed plus 1. What do? I just swapped my x and y. Subtract your 1, so 2y cubed equals x minus 1. Divide by 2. I'm going to leave it y cubed equals x minus 1 divided by 2. Question. If y is being cubed, what do we have to do? Cube root it. Okay. When you cube root this, you are taking the cube root of your numerator and the cube root of your denominator. So what happens? You can't have a radical in the denominator. It's a cube root, so what do I need to do? So we know we have to multiply it because we have to get rid of the radical. Okay, it's a cube root. So I would need 3 of the same factor, right? I have 1, 2. I need how many more? 2. 2 times 2 is 4. This lesson is a huge compilation of what you've learned. Okay, so this y is equal to, when you take the numerator and multiply it, they're both under the radical. So I multiply 4 times the entire x minus 1. So that's 4 times x, which is 4x. And 4 times -1, which is -4. And then my denominator is what? 2, because I had my 3 2's. Okay? So this is all I can do algebraically. What I need to do is now graph it, see if it's a function or not. So for my inverse table, I flip my x and y's. I can't fit the -15, -2, and I can't fit the 17, +2. But recognize that -15 is all the way over here, -2 is right here. So it is sideways. Okay, because it is a cube root function. Okay? But y'all have already done cube root functions. When I graph that and I do the vertical line test, is that a function? Yes. So I'm going to write f to the -1 of x equals the cube root of 4x minus 4 divided by 2. So all cubic inverses will be f to the -1 of x. So as of right now, what we've discussed, what are the only ones that will not be a function for the inverse? Quadratic. I would maybe know that. Okay. Do we have questions over that? That's a big lesson. A lot of material. No questions?